Shout out from West Virginia. Shouting out for somewhere anyways. Okay, I know that you are ready and waiting for joke of the day, so let's get into that. Are you ready? Yeah, let's do it. So why did the pianist keep banging the side of his head against the keys? Just kept banging the side of his head against those keys. Why did he do that? Because he was playing by ear. Okay, well, we are going to take a look at adding and subtracting complex numbers. Now, we've talked about what a complex number is, and we talked about the mathematical model with the business in the front, the party in the back. You've got your real part in the front, you've got your imaginary part in the back. Notice that I'm going to add a couple of complex numbers here, and I'm going to subtract a couple of complex numbers. This complex number is written in that standard form. Here's the real part, here's the imaginary part, business in the front, party in the back. And the same thing on this one. Here's the real part and the imaginary part, business in the front, party in the back. We're going to add these two complex numbers. Now, remember, the I acts like a variable until you see I squared. When you see I squared, you should think -1. But until then, it's acting like an X. Now, remember, addition is commutative and associative, so you can reorder and regroup all you want. So I'm going to employ my associative property here, and I'm going to say, okay, if addition is associative, could I put the A and the C together and add them up? And then could I put the BI and the DI together and add them up? Is that legal? Totally legal, because addition is associative. So now then, remember, this I is acting like a variable, so it's kind of like saying bx plus dx. So if you had a bx plus a dx, what you would do is you would add the b and the d, and then you would just keep that x. And so that's exactly what we're going to do here. So in other words, whenever you add complex numbers, basically you combine the real parts, and you combine the imaginary parts. Combine imaginary parts. So it's kind of like the idea of combining up like terms. So now let's take a look at this idea of subtracting complex numbers. So if I'm going to subtract complex numbers, the first thing that I need to understand is I'm taking this complex number, here's the real part, here's the imaginary part, and I'm subtracting this entire complex number. Real part and imaginary part. They're both in that standard form, that mathematical model with the business in the front, the party in the back. But my point is this. I am subtracting the entire complex number. Not just subtracting the real part, not just subtracting the imaginary part, subtracting both of those parts. So therefore, with that negative or that subtraction right up against the parentheses, what does right up against indicate? Yes, it indicates I'm going to multiply. So in other words, I'm going to distribute that negative all the way through that second parentheses. That should be familiar because that's the kind of thing that we do over and over and over again. So that when I distribute it through, I get a negative C minus a DI, and now that turns it into an addition problem, kicking it back to what we said before. And remember, previously we said, okay, let's put together those real parts. Let's take that A and that negative C and let's put them together. So I'm going to do A minus C. And let's put those imaginary parts, BI and DI, together. So I'm going to do BI minus DI. And just like we said before, let's just go ahead and work those coefficients and retain the variable, because remember, I is acting like a variable right now. I don't see I squared, I just see an I. So it's kind of like an X. So I'm going to take the B and I'm going to subtract the D, keeping the I. I'm going to take those real parts and subtract them as well. So very much like adding those complex numbers, I'm going to subtract the real parts and I'm going to subtract the imaginary parts. The big idea here is that I want to distribute that negative, and here's the key. It's going to be written in all caps. It's that important. Distribute the negative. Here's where it gets really important, all the way through. That's where people make a mistake. They don't distribute that negative all the way through that second parentheses. They distribute it to the first part, they distribute it right here to the real part, and then they quit. But you need to distribute it all the way through the second parentheses. And again, that's why that's written in all caps, because it's so important, and that's where people typically make a mistake. So let's practice now with adding and subtracting these complex numbers. And I've got two examples sitting here because you know that I like for you to feel very comfortable with everything. So in this one, I'm going to add the two complex numbers. Now remember, what I'm going to do is I'm going to add up the real parts and I'm going to add up the imaginary parts, because the associative property says that I can add in any order that I want. So I'm going to put the real parts together, and I'm going to put the imaginary parts together. Now, 13 minus 5 is going to be 8, and a negative 2i plus 6i, if it was an x and it was a negative 2x plus 6x, I would get a 4x out of that. So the I, remember, is acting like a variable right now. It acts like a variable until I see I squared. So right now, I'm going to call that a 4i. Is that standard form with the business in the front, the party in the back? It sure is, because I've got my real part in the front, I've got my imaginary part in the back. All right, so let's take a look at the next example. Notice here that I am subtracting my complex numbers, and I'm subtracting the entire second complex number. So therefore, what I'm going to do is distribute that parentheses, and I'm going to take my 8 plus my square root of a negative 18. Whoa, I got to take care of that as well. So I'm going to distribute the negative through, giving me a negative 4 minus a 3i square root of 2. And I'm going to attempt to put the real parts together and the imaginary parts together, but I'm looking at this and I'm going to wait just a minute. When you see a negative underneath the square root, you should immediately think what? Yes, you should immediately think I. Pull the I out. Probably should have done that in the beginning, but it's okay. If you're asking, wait, should I have taken the I out here and simplified that radical before I distributed through? You could. It doesn't really matter. It's going to work itself out in the end. So what I'm going to do at this point is I'm going to go ahead and take that I out. And when I do, now I'm going to simplify that square root of 18. In order to simplify the square root of 18, remember, I'm asking myself, what would I multiply by itself to create an 18? I can't think of anything. So remember, what comes next is we're going to break it down, break it down, break it down. Oh yeah, those 80s are coming back. Break dancing again. So I'm going to break it down. I'm going to look for perfect squares or pairs. 18 is 9 times 2. Could be 6 times 3, but most people think of 9 times 2, so I'm going to go with that one. But the nice thing about this is, remember, I'm looking for perfect squares or pairs. Do you see a perfect square there? Yes, you do. Because you know that the square root of 9 is 3. So that I'm going to simplify the square root of 9 to just a 3. So therefore, I will have a 3i square root of 2. Now, that I, it could sit here in the back, and some people think of it as 3 square root of 2i. But oftentimes, because what people do is they say, well, if the I is acting like a variable, I put my variable in the back. However, a lot of times we get very sloppy with our square roots, and we drag them out, or we don't make them long enough. And so it's hard to figure out, is the I under the square root? Is it out of the square root? Where's the I sitting? So convention says, let's put the I up here, and that way the only number that's back here has got to be under the square root. So the I is not under the square root. I'm going to slide it out here in the front. Just makes it a little bit cleaner, and there's no guesswork as to what should be under the radical. So now I've simplified everything. I'm going to put my real parts together. I'm going to put my imaginary parts together. So I'm going to take my 8 and put it with my minus 4. And then I'm going to put together my imaginary parts, the 3i square root of 2 minus the 3i square root of 2. And remember, 3i square root of 2 minus 3i square root of 2, they're going to completely cancel each other out, because if I have something and take all of it out, there's nothing left. And an 8 minus 4 is just a 4. Now, don't have a heart attack if you start with complex numbers but you end with a real number. It's okay. Sometimes your complex parts, or your imaginary parts will cancel out. Don't have a heart attack if you start with complex numbers and you end with only an imaginary number and your real parts cancel out. It's okay. You followed everything properly. You did what you used all your laws and properties correctly. So we're going to end up with just a real part as this complex number, just the real part of the complex number. So I hope that helps with adding and subtracting complex numbers. Remember, the whole idea is this. Because not multiplication, but because addition is associative, you can reorder and regroup. So combine up those real parts, combine up those imaginary parts. And remember, if you are subtracting complex numbers, you need to distribute that negative all the way through the second parentheses, because then it kicks it back to an addition problem. You're going to combine up your real parts and your imaginary parts. I hope that helps. Have a great day.